They had the blueprints, they had the factories. They still couldn't build it right. For the Germans, that was the most humiliating part. Not the aircraft itself, but the failure to explain the failure. They understood aircraft. They'd spent the previous decade building some of the finest in the world. The TA-154's aerodynamics weren't obviously deficient. The engines were capable. The design logic was sound. Yet the airframes kept failing. And the reason, when it finally became clear, was something no intelligence photograph had ever captured, and no captured example had ever revealed. Something so mundane it barely warrants a second glance on a peacetime factory shelf. Before we arrive there, the Mosquito deserves a proper introduction. In the late 1930s, Geoffrey de Havilland approached the Air Ministry with a proposal that most reasonable men considered professionally embarrassing. He wanted to build a frontline combat aircraft from wood. Not partly from wood. Wood as the primary structural material, spruce in the nose section, birch plywood for the fuselage, a composite sandwich technique using balsa cores positioned between outer plywood skins. The resulting structure would be shaped and formed by craftsmen rather than riveted by metalworkers. In an era when every serious manufacturer was advancing towards stressed skin aluminium monocoques, de Havilland was proposing to go the other way entirely. The Air Ministry's reception was cool. The concept of a wooden frontline combat aircraft struck the establishment as retrograde, a step backward to a technology the industry had already moved beyond. There were genuine concerns about structural integrity, moisture resistance, and whether a wooden airframe could survive the stresses of combat flying without progressive degradation. De Havilland's counter-argument had a logic that was harder to dismiss than the Air Ministry initially admitted. Britain was burning through aluminium. The supply chains servicing Britain's metal aircraft manufacturers were stretched to their practical limits, and the labour pool of skilled metalworkers was already fully committed. But Britain had something else. A furniture-making and cabinet construction industry of world-class quality, employing craftsmen who'd spent their careers working with wood at levels of precision that most industrial processes couldn't match. Those workers weren't yet building aircraft. They could be. Their skills transferred directly to the kind of precision woodworking a composite wooden airframe required. It took pressure, a changed wartime calculus, and some pointed demonstrations before the Air Ministry conceded the point. When prototype W4050 lifted off from Hatfield Aerodrome on November 25, 1940, piloted by Geoffrey de Havilland Jr. and flight engineer John Walker, the institution that had spent 2 years resisting the project found itself watching something it hadn't anticipated. By February 1941, W4050 had recorded 392 miles per hour at 22,000 feet during trials. That figure wasn't merely impressive, it outran the contemporary Supermarine Spitfire Mark II. An unarmed wooden aircraft was faster than the RAF's frontline fighter. The Air Ministry stopped resisting. The production Mosquito that followed was built on the same principles: balsa core sandwiched between birch plywood skins, spruce framing, the whole assembly shaped by cabinet makers and furniture industry workers who'd been redirected into the aviation supply chain. The finished aircraft was light, stiff, and aerodynamically clean in ways that aluminium construction of the period would have struggled to match at the same weight. The wood construction, dismissed as primitive, turned out to be one of the most sophisticated structural solutions in wartime aviation. What followed operationally was close to unprecedented. During the Mosquito's first 600 bombing missions, 1 aircraft was shot down. 1. RAF medium and heavy bombers of the same period were losing roughly 5 aircraft per 100 sorties, a loss rate that, translated into human terms, represented industrial-scale attrition of aircrew. The Mosquito flew above the reach of most German interceptors, faster than anything that tried to chase it, operating as a bomber, a night fighter, a pathfinder directing larger raids, and a long-range photo reconnaissance platform. Total production reached 7,780 airframes, built across England, Canada, and Australia. Its loss rate across all those roles remained consistently lower than any comparable RAF type. By 1942, the Germans had seen enough. Erhard Milch, responsible for German aircraft production, put the formal requirement to Fokker-Wulf in September 1942. Build a twin-engine night fighter capable of intercepting and destroying the aircraft that had been flying over Germany with alarming freedom. Build it from wood, because Germany's own strategic materials situation was under comparable pressure. The mandated composition was precise: 57% wood, 30% steel, 13% duralumin. The engineer who took the brief was Kurt Tank. He'd run Fokker-Wulf's design department since 1931. He'd produced the FW-190, one of the Luftwaffe's most capable fighters. Tank wasn't a man who failed through incompetence. His new aircraft was designated the TA-154, the prefix derived from Tank's own name. The Luftwaffe called it the Mosquito. They meant it as competitive acknowledgement, maybe even as flattery. The design shared genuine structural similarities with the British template. Twin engines mounted ahead of a wooden fuselage, the airframe composed primarily of laminated wood sections bonded together. German intelligence almost certainly had access to downed Mosquitoes and had most probably examined their construction in general terms, enough to understand the broad approach. The aircraft had been originally designated the TA-211, referencing its intended Jumo engine specification. When that changed, the aircraft was redesignated the TA-154. The Luftwaffe's nickname, Mosquito, stuck regardless. Tank's team pressed forward through 1943, and the V1 prototype flew that year with Flugkapitän Hans Sander at the controls. Then the program began its long, expensive unravelling. The V1 crashed on July 31, 1943, when the landing gear collapsed on landing. The V3, V4 and V5 followed with their own failures: landing gear collapses, stress concentrations in the wooden airframe that the engineers couldn't resolve satisfactorily. On the 6th of May 1944, the V8 prototype suffered a catastrophic crash when an engine fire killed both crew members, pilot Otto and radio operator Rettig. The crashes weren't all attributable to a single cause, and it would be wrong to trace every early failure to what would become the program's defining problem. The TA-154 had genuine engineering challenges that existed on their own terms, but the material difficulties were already in motion. On the night of 29th to 30th May 1943, 719 RAF bombers flew over Wuppertal. The breakdown of that force, 292 Lancasters, 185 Halifaxes, 118 Stirlings, 113 Wellingtons, and 11 Mosquitoes. The raid produced a firestorm. Approximately 80% of Wuppertal's Barmen district was destroyed. Roughly 3,400 civilians were killed. Wuppertal was targeted because it was an industrial city of genuine military significance: chemical manufacturing, synthetic production, supply infrastructure. The RAF's area bombing doctrine of 1943 didn't require individual factories to be separately identified and designated. The city was the target. Everything within the bombing footprint was, in the practical terms of the campaign, a valid outcome. One of the buildings inside that footprint belonged to T.H. Goldschmidt AG. The Goldschmidt plant in Wuppertal manufactured a phenolic resin adhesive designated Tego film, a paper sheet impregnated with Resol phenolic resin, delivered in rolls, specified by the Reichsluftfahrtministerium as the bonding compound for the TA-154 program. The Goldschmidt facility was the sole producer. When the Barmen district burned, the adhesive supply for Germany's wooden aircraft program burned with it. Whether British intelligence knew any of this when it designated Wuppertal as a target is a question the available record can't answer cleanly. No confirmed source establishes that the Goldschmidt factory was specifically identified, or that anyone in RAF planning drew a direct line between that facility and the TA-154 program. The bombing was a broad industrial campaign, and the destruction of the Tego film plant appears to have been incidental to a larger objective. The evidence stops short of confirming deliberate targeting. What the record does confirm, with a precision that almost demands a pause, is that among the 719 aircraft over Wuppertal that night, 11 were Mosquitoes. The aircraft Germany was attempting to copy helped eliminate Germany's capacity to make a workable adhesive for its copy. Whether anyone intended that particular outcome, we genuinely don't know. What happened next, we do. With the Goldschmidt plant gone, the TA-154 program needed a substitute adhesive. The substitute sourced was too acidic. To understand why that matters, consider what a wooden airframe actually does in flight. A glued wooden structure isn't static under operational conditions. At altitude and speed, the airframe flexes under aerodynamic load. Temperature differentials between ground and operational altitude cause wood to expand and contract. Vibration from engines and air turbulence transmits through every joint continuously. The bonding compound holding the laminate sections together manages a constant series of microstresses across every glued surface. It isn't simply providing rigidity, it's mediating movement. A joint that performs adequately under static conditions on the ground may behave entirely differently under those cumulative stresses in flight. A bonding compound with elevated acidity doesn't fail immediately. The acid works gradually, degrading the wood fibers at the bonded surfaces, weakening each joint incrementally over time. From the outside, the aircraft looks intact, the bond appears sound. There is no visible indication of what's occurring at the microscopic level within those laminated sections. The degradation accumulates invisibly until the joint can't handle a load it was previously managing, and then it can't handle it very suddenly. Several TA-154 airframes broke apart in flight. Source in the academic record states the outcome with a brevity that fits the finality, causing several TA-154s to break up and crash. Consequently, the TA-154 was cancelled. An engine fire, however fatal, is a comprehensible mechanical failure. An airframe separating at altitude tells the people responsible for a program something far worse: that the fundamental construction method is compromised, that the aircraft can't be trusted to hold together in the environment it was designed to operate in. By mid-1944, each completed TA-154 airframe required 12,000 man-hours of labour. That figure was already extraordinary before the adhesive problem surfaced. It reflected Germany's critical shortage of experienced aircraft woodworkers, a gap that had no ready solution. The program was expensive, slow, and was now producing aircraft with a structural integrity failure it couldn't resolve. Cancellation was the only rational outcome. Now here is what Germany missed. And this is the part that extends beyond the war, beyond the specific aircraft, beyond this specific program. When German intelligence examined captured Mosquito airframes, they could see the wood. They could identify the species, spruce, birch, balsa. They could measure the laminate layers, identify the sandwich construction technique, understand the geometry of the structure. They could, essentially, read the blueprint of the aircraft's construction. What they couldn't see, in any analytical sense that led anywhere useful, was the compound bonding those layers together. That compound was aerolite. Aero Research Limited was founded in Duxford, Cambridgeshire, in 1934 by a scientist named Dr. Norman de Bruyne. His company made adhesives for aviation applications. The product that ended up in every Mosquito airframe was a urea formaldehyde resin, developed through years of rigorous materials research into how wood behaves under stress and how a bonding compound can be formulated to work with the structural properties of the material it joins, rather than simply filling the gap between surfaces. A correctly executed aerolite joint achieved tensile strength approximately 3 times greater than spruce wood itself. The bond was stronger than the material it bonded. Under stress, the wood failed before the joint did, and that is precisely the design criterion you want in a structural adhesive. The failure mode is predictable, and it occurs in the material you can see and replace, not in the invisible chemistry holding the structure together. Aerolite used gap-bridging hardeners incorporating formic acid, but at concentrations carefully calibrated to achieve cure without degrading the wood substrate. The formulation was the product of deliberate chemistry, not an approximate industrial process. It had been developed specifically for aviation-grade wood bonding, and it performed accordingly. Under aviation-grade temperatures, under aviation-grade stress cycling, with aviation-grade reliability. Tegofilm was a different compound in almost every relevant sense. A resol phenolic resin, rather than a urea formaldehyde resin, applied as an impregnated paper sheet rather than as a liquid compound. Under normal circumstances, with the Goldschmidt facility intact and the specified material in the production line, it had been doing its job. When the replacement entered production after the Wuppertal raid, the acid chemistry was miscalibrated for the application. In a wooden airframe, an adhesive that is out of tolerance for its application does not fail predictably or safely. But the chemistry was only half the problem. The other half was in the hands of the workers. The de Havilland craftsmen who built the Mosquito knew aerolite through practice. The furniture makers and cabinet workers recruited from Britain's woodworking industries brought with them a professional familiarity with timber and bonding compounds that translated directly into proper joint preparation, proper application technique, and proper curing management. Knowing how to prepare a wood surface before bonding, knowing how to control application thickness, knowing how to read the material under different humidity conditions. None of that knowledge was written into a technical manual in terms accessible to intelligence analysis. It lived in the hands and judgment of the workforce. It was transmitted through training and through the accumulated experience of an industry that had been working with these specific materials and compounds since 1934. Germany's shortage of experienced aircraft woodworkers was itself a symptom of the same gap. The furniture and cabinet industries that fed de Havilland's production lines represented a British industrial inheritance with no immediate German equivalent at scale. When the TAR 154 required 12,000 man-hours per airframe against a fraction of that for a Mosquito, the disparity reflected something no blueprint could address: the embedded knowledge of a workforce that had been doing this specific work in this specific way for years. Some knowledge doesn't travel by blueprint. It travels through practice, through apprenticeship, through the accumulated craft intelligence of an industry that has been doing something one particular way long enough that the doing becomes instinctive. Britain had been working with aerolite and with the woodworking traditions surrounding it since 1934. Germany was starting from scratch in a crisis, with an inferior substitute, after the factory making its most viable alternative had been levelled by a bombing raid that may or may not have known what it was destroying. The Mosquito, meanwhile, didn't slow down. While the TA-154 program was consuming 12,000 man-hours per airframe and losing aircraft to mid-air structural failures, the aircraft it had been designed to counter was flying over Germany with the same operational freedom it had always enjoyed. The loss rate across the Mosquito's first 600 bombing missions, one aircraft shot down, stands as one of the most striking statistics in RAF history. RAF medium and heavy bombers were losing 5 aircraft per 100 sorties. The Mosquito was losing less than 0.2%. That's not a capability gap. That's a different category of aircraft, operating in a different threat environment entirely. The Pathfinder force relied on Mosquitoes for their speed and altitude ceiling. Raids on Berlin, the most heavily defended target in Germany, included Mosquito operations at altitudes and speeds that reduced interception to a matter of limited options for German night fighter crews. The aircraft the Luftwaffe had available simply couldn't intercept in time. The aircraft commissioned specifically to close that gap never entered operational service in meaningful numbers. It disintegrated, quite literally, over Germany's own test ranges before it got the chance. Total Mosquito production reached 7,780 airframes. The aircraft outlasted the war and flew operationally into the post-war period. Aero Research Limited had been quietly operating in Duxford since 1934, a Cambridgeshire company that barely appears in the histories. Erhard Milch asked Focke-Wulf to build Germany a Mosquito. Kurt Tank's team, talented, resourced, and working from genuine examples of the aircraft they were copying, produced something that looked right and flew briefly before falling apart. The Luftwaffe's night fighter gap, the one the TA-154 was supposed to close, remained open throughout the period that mattered most. Every hour spent building an airframe that would eventually be cancelled was an hour not spent on aircraft the Luftwaffe could actually put in the air. They had the blueprints, they had the factories, they still couldn't build it right. The answer was aerolite, a urea formaldehyde resin in a tin made by a company in Cambridgeshire that most people have never heard of, founded by a scientist named Norman de Bruyne 11 years before the war ended. Germany captured the shape of the Mosquito, the dimensions, the material ratios, the structural geometry. It couldn't capture the specific chemistry of the bonding compound, couldn't replicate the craft knowledge of the workers who applied it, and didn't survive the loss of its own substitute manufacturer to an RAF raid that may or may not have understood what it was targeting. While German engineers were sourcing acid-laden replacement adhesives and watching their airframes break apart at altitude, the Mosquito was flying over Berlin, unopposed. Made of wood, bonded with a compound that came in a tin, built by furniture makers repurposed for war. The quiet British victory that never made the history books had a very specific address: Aero Research Limited, Duxford, Cambridgeshire. Subscribe for more stories like this, the ones where the decisive factor never made the history books because it came in a tin rather than a gun.